Alrighty, we are talking about Venn diagrams. Some of you may have seen a Venn diagram as something in English class when you're comparing two sources, or in social studies when you're comparing two events or groups of people or something like that. In math, we use Venn diagrams in a similar way, but we have some special things we want to consider and some special words we use. So Venn diagrams in math are models, meaning that they show us information, and they display two or more different subsets or sets. So there have to be at least two different groups, okay? But we can have more. Sets and subsets are just ways of saying groups in math, and specifically groups of data, okay? And what is it showing us about those groups? It's not telling us the name, or it's not telling me qualities about them. It's telling me their survey sample data, meaning a data from a survey. Now, sometimes the survey can look more like an experiment, but often it's a question. So these examples we're going to give are using this question. A survey asked 40 people, do you like apples and do you like bananas? Their results are shown in the Venn diagram. So you can imagine the A stands for apples and the B stands for bananas. So those circles indicate everything. So this blue circle here indicates everyone that said that they liked apples. Everyone in the B circle says they like bananas, and everyone in this shaded area, or this shared overlap shaded area here, said they like both apples and bananas. Now you'll see I have 2 on the outside. That is still a part of the set, and that is someone who said no or didn't like either of them. Now, before I get into this is my little check to see if you are listening to the video and not just watching it and pausing it. I do encourage you to pause, and you can turn on captions if that works better for you. But if you are watching this and you hear this message, my encouragement to you is to write on the top of a piece of quarter paper, or on a quarter sheet of paper, your name, and write the word blue. Okay, write the word blue, B-L-U-E. Okay, getting back into our math. First, I want you to write the word sub here. I should have written that and mistyped it on your version. But a subset is like one group. Okay, so a situation talking about the probability of a subset would be the probability that a person likes apples. They like, or is, and then it's just one thing. So our keyword is like the like or is, and then just one thing. And if I were to shade in on my Venn diagram, what is this talking about? Well, it's talking about all the people that liked apples. So it's everybody in this section. I encourage you to highlight or shade in everything in that section to make it match with mine, okay? That all those people like apples. They might just like apples, or they like apples and bananas, but they for sure like apples. So this is the probability of apples, which is equal to, and then we're going to find it the same way. So out of our 40 total people, we have 16 plus 18, which is equal to 34 out of 40. So that's our probability that someone likes apples. That's like what we've been doing as we do just singular probabilities, writing out probabilities, is using that sort of idea. Okay, the union. If you think about a union is something that brings a lot of people together. Sometimes people talk about marriage as a union, so it's the bringing of things together. A situation that shows a union is the probability a person likes apples or bananas. So they could like apples or they could like bananas. So our key word here is or. And on our Venn diagram, a union is that place where we see that over. It includes, the place that includes anything that answered yes. So they might like bananas or apples or both. As long as they like one of the two, they are included in our Venn diagram or in our grouping. Okay? When I write the probability, I have a special symbol. I use A, and then I use like an upside down U, or not an upside down U, a U and a B. So this means the probability of A unioned with B, or A or B, which is equal to 16 plus 18 plus 4, so taking all the probabilities of the sections we've shaded in, over 40, which is equal to 38 over 40. All right. The next type is sort of the other side of things from a union, an intersection. Well, if you think about where cars cross, that's called an intersection. So where things cross, our keyword in our sentence, the probability that a person likes both apples and bananas, our keyword is and. And specifically both and. I should be more specific. We want to see both the words both and, saying that we are looking for two different things. So this is where we're just looking at that overlap or that cross section, where the person agrees that they like apples and bananas. And our symbol for the probability of an intersection is like the opposite of a union. It's an upside down U, or like an N, or like a bridge. Okay. Probability of A intersects B, which is equal to 18 over 40, because that's the number in that section over the total number of people surveyed. All right, the next situation is conditional. This is a conditional that a person likes only apples. Okay, likes only. Meaning that we do not want to include an intersection. So when I color this, I'm looking at people that like apples, but they don't like bananas. I don't want to include the people that like both apples and bananas, just the people that just like apples, which would be our 16 that is not overlapping. Okay. Okay. All right. So when I write this out, I'm looking at the probability of A, but there's a section I don't want to include. And if I want to remove something, I'm going to write subtract. Well, the section I'm subtracting is the intersection. So I'm going to write minus A intersects B. That's how you find the probability of a conditional or of one piece. Okay, just the A without the shared. Okay. Now, sometimes you will have to find the actual probability of A and the actual probability of the intersection and subtract them. Sometimes, like in this one, we're given that number that's on the outside. So our answer is just 16 over 40. Okay, we just take the number we are given. All right, the last two are kind of similar. The complement of a subset. So a subset means one group, and the complement in math means the opposite. So a person does not like apples, not, and then one group. Okay, so we want everything except for apples. So if it includes apples, we don't want it. So we want the people that like just bananas and that didn't like anything. Okay. I don't want the people that like bananas and apples because that includes apples. But I do want the people that didn't like anything. So that's why I shade around the whole rest of the rectangle that our Venn diagram lives within. So I can include those two people that didn't like anything. And the way we signify complement is we write what is it that we're trying to find the opposite of, and then we put an apostrophe after. So this means not A. Well, what are the things that don't include A? We have the 4 people that don't like bananas, or that like bananas but not apples, and the 2 people that didn't like anything over our total, which is equal to 6 over 40. All right, and our last terminology is the complement of the set. So this is when I say the set, that means the yes data, or in the circle. So we want the opposite of what's in the circle. They want neither, we want the probability that a person likes neither apples nor bananas. So our language is neither nor. Neither this nor that. Okay? We don't want either of them. So the only thing we want is who does not like anything, and that is our one person on the outside, because we do not want to include our circles. Okay, we want the opposite of our circles. And now if I think about how I'm going to write this, before I think about how I want to write this, I want to think about what is it that I'm finding the opposite of. Well, the opposite, why is it clicking like that? Now I can't even find my pen. Hang on, people. Delete. We want the opposite of all of what, oh, that's not what I wanted either. My goodness. I want the opposite of everything that's in a circle or a shared circle. So if I think about what is it that actually creates this, what I just circled is a union. So I want to find the probability of the opposite of the union. So the probability of the union, but we're finding the opposite. So I put my dash on the outside because I want the whole opposite of the whole union. Okay, well, what's on the outside of our union? It's 2 out of 40. It's important that if we're finding the probability, we're writing it over the total. If it's just asking for the number, you do not need to put it over the total. In fact, you shouldn't put it over the total, and instead you should use the unit, so people. Okay, so 2 people. But for probability, it's 2 out of 40. I have some examples to walk us through this. So this first example, we have R and V, okay? And I'm looking at where do they cross. Well, where do they cross is called the intersection, okay? And our symbol would be R intersects with V. The next one, I'm looking for everything except for V, which would be the complement of V, because I shaded everything except for what was in the circle labeled V. So my symbol would be V with a dash or an apostrophe. Lastly, I have all of my circles shaded in. That is called the union. Union. And the symbol I use for union is R-U-V. Because it does not ask about the probability, I do not need to write P parentheses. If it did ask about the probability specifically, then I would have P parentheses, R intersects V, P parentheses, V not, P parentheses, R union V. So an example for us, it says a group of students was given a survey to ask about the classes that they like this year. How many students responded to the survey? So I want to total up all my values. So I have 18 plus 51 plus 20 plus 39. And when I add all of those things together, I find that that equals 128 people. Now, like I said, we want to put units on things as we're working. The next question says to shade in the area representing the students who like English or biology. Or is our keyword for union, which means we're going to color in anything. Oops. Oh my gosh, I'm struggling to color here, people. Anything that is, oh my goodness, in one of the circles. Okay. There we go. All right. So that is our union, and then it's asking about the probability that a student liked English or biology. So that again is our union. So we're going to write the probability of English or biology. Well, that is going to be 51 plus 20 plus 39 over our total 128 people, which is equal to 110 over 128. That is the probability of something in our union, which is English or biology. Now it says, how many students did not like biology? Well, now I'm looking at, let me get my pen ready. Did not like biology. Well, they can't like English or biology. So I'm looking at this blue circle, and I'm looking at anything on the outside of that blue circle, which would be my 18 and my 51. Okay. So I'm going to add those two together. 18 plus 51 is equal to 69 students. Again, it's important we're putting our units on to signify whether I'm finding a probability or am I talking about a number of people. And in this case, it's asking about how many students, so I write the units student. Letter D says, what is the probability that a student likes both English and biology? Well, both and, that's our key language for an intersection. So I'm looking at what's happening on the inside, and I see that the probability of E and B is equal to 20 over 128. So that is the probability of that intersection. And lastly, it says, what is the probability that a student liked English but not biology? Okay, so English alone, no biology. That would be just the English circle that I'm coloring in now. And we write that, remember, this is our conditional situation, so I'm going to write it as P of A minus that intersection. We happen to have the information, so I don't need to actually do the subtraction, but I put 51 over 100, over 1, oh gosh, I'm sorry guys, my pen is not calibrated, 128. Okay, 51 over 128 would be the probability of English, not biology. All right. So those are some different situations that are using a Venn diagram to help us find the probabilities of different situations.